Hey everyone, as part of the monthly.com engineering course with Mark Rover, our project number 2 needs to be something that makes art and is powered by an Arduino. This will be my submission for that project. What I'm building is an Arduino powered spirograph. Let's take a close look at the parts that will be used. Here's the main body of the spirograph. It's made up of the base section that is raised up on legs so that we can house the electronics and the motors underneath. The top rotating plate that will ultimately hold a piece of paper with a pen suspended over it. This pen will rotate and create the spirals on the page as it goes around. Let's have a look and see what's going on underneath. Underneath the spirograph you can see that we have a 12 volt 72 RPM motor connected to a couple of acrylic gears that I've cut. As this spins at 72 RPM it would rotate the table far too quickly. I want this spinning at about 1 RPM. So what I've done is cut a couple of gears that step it down. So we have a 1 to 8 reduction and then a 1 to 9 reduction, giving us a total of a 71 to 72 reduction from 72 RPM down to 1 RPM ultimately. When it's powered on in the final build, it will work like this. This should result in the page rotating 1 full revolution once per minute. Hopefully that will be slow enough to create very interesting spirals on top. The other components involved in the build are an Arduino Mega, a 5 volt stepper motor and its control board that came with the starter kit that I bought, a second 5 volt stepper motor, a relay which will control the 12 volt motor that is underneath the Arduino, a couple of momentary switches, a 5 volt power supply that came with the starter kit, and a mini 128 by 62 LCD screen that will be wired up to give us some prompts as we go. Okay, so I cut the first of the armatures that will attach to the servo motors out of acrylic. In place they will look approximately like that. It turns out trying to calculate the distances that are required for the length of the arms is far more complicated than I thought. Hopefully this graphic will result in arms that don't end up pulling the pen off the page entirely, which would be a big problem. Time to cut the acrylic. Here we have the two arms. This one here will attach to the pen. And this one here will attach to the second motor. And have a pin in there to hopefully give some rotation. So it turns out making the mechanical components of the spirograph is more difficult than I thought. Here are my first arms that I calculated and glued up and put on. And as you can see, through most of the rotation, it won't be an issue. I've calculated so that at its furthest point down, it still remains on the page. Where I run into problems is if this motor spins out to here and this motor spins that way, you'll see the pen ends up off the page. So, time to revise. I think what the problem is that the length of this arm is creating too great a movement for the size of the board that I've got. So I've cut some smaller ones. I'm going to glue them on with some acrylic glue. Hopefully that will reduce the range of motion and I might be able to position it to keep it somewhere on the board. Okay, take two. Here we are with the shorter arms and the stepper motors. Position approximately where I think they're going to end up. And now if we just wiggle them through the full range of motion, should find at the lowest point we're well and truly still on the page. We don't exceed this limit here. Or that limit over there. So at all times the pen will remain somewhere in this kind of area. So it looks like that'll work. Here's the final build complete. It contains two 5-volt stepper motors which will run independently of each other in independent direction and independent speed. A 12-volt 72 RPM motor underneath the table which is geared down to 1 RPM which will rotate the table as the pen moves. The way it works is you power on the system, get a logo, and it will say remove pen now, press button when ready. You remove the pen. When you press the button, both the stepper motors will pick an independent direction and speed and initialize them to a random position. This ensures that every time you run the program, you're going to get a completely unique spiral that's very unpredictable. It now says insert the pen and press the button when ready. So we insert the pen, we press the button. When we press the button, both the stepper motors will commence rotating in their chosen direction and speed, and the relay will kick off the 12-volt motor to start the spiral. As you can see on the screen displayed, I took a leaf out of Mark's book and I've used his logo and created a little screen that says inspired by Mark Rober. When I was coming up with the idea of what I wanted to do, I deliberately wanted both the motors to choose a random direction and random speed independent of each other so that I could learn to program an Arduino the way I wanted it to. Unfortunately, I think what I've done is outsmarted myself, and now it's so random that whilst it is a repeating pattern, it's not typical of your normal spirographs where both motors run the same direction and same speed. You'll find that over time this spiral will be repeated, but it's so complicated and so difficult to see that I think what I've created is a scribble machine. Logically it makes sense. In practice it produces very interesting and unique spirals. And given the fact that each motor runs randomly compared to the other one, every time you start a new spiral you never know what you're going to get. It'll look completely different to the one before it. Anyway, we'll let this run for a bit and we'll see what sort of design we get out of it. Okay, we've changed the paper over. Let's reset the system. It'll randomise itself again and we can see what we get this time. So we've reset it, goes back to start. It'll ask us to remove the pen, press the button. It will now randomise the two steppers. Random position. Let's see what we get this time. And just to prove the complete random nature of this machine, let's see what happens if we do a third one. Again, because the machine will choose random rotation and speed for the two stepper motors, plus a random start position, who knows what this one will look like. Let's have a go and see what happens. Let's randomise the start position. Insert pen. See what happens. So there you have it. Mark challenges to make art using an Arduino. I think my submission qualifies as art. I've met my design criteria in that I wanted random spirals each time the job ran so that it will be completely unique and I never know what I'm going to get. You can get anything from the fairly basic to the very complicated. Is it art? I'll let you be the judge.